This video is going over patterns and sequence, preferably the PFA, but also just some general knowledge on patterns and sequence. So the first thing we're going to view is some key terms in order to make sure that we are understanding what each part actually means, either for the equation or what the questions are asking. So, when you see the word term, this is referring to a number in a sequence. So 3, 5, 7, 9, those are all numbers. All those numbers are terms. This is my first term. This is my second term, my third, and then my fourth. Because they're all in a sequence: first term, second term, third term, fourth term. Okay? Now, when referring to the first term, also called the initial value, the starting point that we've been talking about all year, this is the first number in the sequence. So for these numbers up here, the first number in this sequence of 3, 5, 7, and 9, the first term is actually going to be 3. That's what they tell us to start with and what is given to us. So that is our first term. Now, the difference between the two terms is one of them is arithmetic sequence. So this is a pattern in our sequence when we're adding or subtracting the same term or the same common number. So, such as here, from 2 to 5 is 3. From 5 to 8 is 3. 8 plus 3 is 11, and 11 plus 14 is 3. Those are adding by 3. So that's an arithmetic sequence. You can also think about it like basic math. That's arithmetic is another word for math. So a subtracting term that would be an arithmetic sequence would be 7, 3, -1, -5. Well, I know from 7 to 3 is going to be subtracting 4. And if I continue on, again, we're subtracting 4 forever and ever. So in your PFA, or just some common knowledge, common difference is going to be what arithmetic is referring to. So adding or subtracting to get the next term in arithmetic pattern. This term can be positive, which would be adding, or negative for subtracting. So in the examples up here, 3 is a common difference. So the common difference would be 3, so it'd be plus 3. For this one, it would be -4, or a -4, because we're subtracting each time. Now looking at the difference between arithmetic and geometric. Geometric, think about like shapes and things. If we're getting larger or smaller, we're multiplying or dividing. So this is when we're multiplying, obviously, or dividing by the common term. The number that we're multiplying or dividing by. So from here to here, from 1 to 2, 1 to 2, okay, I could figure if it was an arithmetic sequence, but if I continue on, I can see that it's actually a geometric, because we're multiplying by 2. Or if you are dividing by a half of 1/2 times 2 would give you just essentially multiplying by 2, which would still give you 4. So here we're multiplying here by 2. Now, as you can see, the second one down here, they're getting smaller. So I know that that must be dividing. So in this case, 64 to 16 would be dividing by 4. And if I didn't know that, I could definitely look here at 16 and go, what divided by 16 will give me 4? 4. So in this case, this is dividing by 4. Now, common ratio goes with geometric sequence, also known as the growth factor or the multiplier, because we're multiplying or dividing. So that means it's getting super big or super small. So in these examples, 2 is the common ratio for the first sequence here, and 1/3 would be the ratio for the second if I was going to divide. Okay? So those are some common words that you're going to see throughout this lesson, as well as your PFA and anytime you're dealing with patterns and sequence. So now I'm going to show you what the difference between, again, arithmetic and geometric sequences are in a formula way. So let's get ready. So at this point, we have 2 actual equations for arithmetic and geometric sequences. So I want you actually to pause this video first and write out what the arithmetic sequence is and a geometric sequence is. Now that you've paused it, now I'm going to explain what each of these parts mean. Obviously, we have a key over here, which would be very crucial to write. But if I was looking at arithmetic sequence, okay, this AN essentially is my Y. This says my final answer, this is what it is, okay? So A sub N is going to be the term we're looking for. The answer to the term we're looking for, okay? Now A sub 1 here, that's going to be our first term. So if our first term in our sequence of 3, 6, 12, and so on and so forth, my first number would be 3. So this is the first term you are given in your sequence. Okay? So now this n minus 1. So when we're actually looking for the answer to our term, so let's say we're looking for the 10th term, okay? So assuming we're looking for the 10th term, this n is actually the term number we are looking for. Oops. Okay. So the n, first off, is the term we're looking for. The whole giant thing here, this n minus 1, okay? The reason we have to subtract 1 is, if you think about it, the term before it, I'm adding whatever the difference is from it. So if I was looking, let's see, if I was looking at pattern 3, 6, 9, 12, okay? This is an arithmetic sequence. They're increasing by 3, right? If I wanted to figure out, let's say, the 30th term here, I could continue on and on and on forever. But what I need to know before I add my original 3 here, my first term, is I need to know what the 29th term is. That's why we're subtracting 1. So n minus 1 is the term before let me erase this real quick. So the term we're looking for before we solve our answer, okay? And D, right here, our little d, is the common difference. So how much it's changing by, or, how much it's changing by. So, such as, if my common difference is 3, that would be my difference. That's how much it's changing by each time for each term. Okay? So take a brief second, get the arithmetic sequence down, and then we'll go over the geometric. All right, so now let's look at the geometric. Same thing here. The term we're looking for is going to be this a sub n, okay? So that's the nth term in the sequence, the term we're kind of looking for. This a sub 1 is going to be the first term in our sequence. Same thing, okay? So here's where the difference is between these two. As you can see, the r actually is the same thing as the d. How much it's changing by. Or the ratio. So the common ratio, such as if I have a pattern such as 3, 6, 12, 24, and so on and so forth, I can see that this from 3 to 6 is actually multiplying by 2 by the previous term. So my ratio would be, or the difference would be 2. Now again, this a sub n, or sorry, n minus 1 is going to be the term we're looking for before it. Meaning, okay, so if I needed the 10th term of this sequence, and I don't know what it is, I need to know 10 minus 1, which is 9. I need to know the 9th term before I can actually figure out what the 10th term is, because we're multiplying it by 2, as well as what we originally started with. So the cool thing is to remember, these are multiplying. Okay, this is r to the power of n minus 1. Okay, so it looks something like this if you're trying to write it. It's a little hard to see, but if it isn't hard to see, here's again what it looks like. So since we did a lot of vocab in this video, I'm going to show you an arithmetic sequence first, and then a geometric sequence. So here's our first arithmetic sequence. This actually gave you the equation. So let's see what it is. So the -6 actually is what let's look at our vocab, what our first term is. So this is our first term. Okay, I don't know what the heck happened there, but that's our first term. The 5 is how much it's changing by. So it's adding 5 each time. Each time it's increasing by 5. Now, it says find the 8th term in the sequence, meaning I'm going to take this 8 and plug it in right here where this n is. So essentially, I have -6 plus 5 times 8 minus 1. Well, what's 8 minus 1? 7. Because I need to know the 7th term in order to figure out what the 8th term is. So I have 7 times 5, which is what? 35. You're right. So now I have 35 plus my -6, because that's where I originally started, which is going to give me what? 29. Perfect. Good job, guys. So now what I'm going to do is I'm going to plug in 29 here. Aha! It worked. So I'm going to put the 29 there. I'm going to hit check answer. And woohoo! We got it right. So let's do one more arithmetic sequence. So as you can see here, it tells us our first term here, this B1, our first term is 16. So this is our first term. All right. So wherever I see the first term here, I'm going to plug it in. So let me zoom in here. With 16 here, this B1 equals 16. This is how much it's changing by each time. So what I'm going to do here is put this B1 right here. So now I have 16 times, I'm looking for my second term. So 2 minus 1 plus 1, because that's the 1 is my first number in my sequence, which 2 minus 1 is 1. So I have 16 times 1 plus 1. So in this case, I have 17 is my second term in my sequence. So I'm going to actually have a second video for geometric, so we can see what the difference between those are. So stay tuned for part 2.